This conference will now be recorded.
Hi, folks. It's actually in the month of August. Thanks for accommodating the change of time for this month's monthly meeting. So today we have a couple agenda, pretty full. So TSFF, OCP Global Summit, SI Test Feature Update, Gen 6 discussion. Hopefully Tama will join us later. And then also the dual wide small factor. So in this mode, I couldn't see let me bring it up.
Damien, I'm here.
Yeah, here's Tannoy. Great. Yeah. I also want to make sure that Anon is here. Yes, Anon is here as well. And I heard Jason, so he's definitely here. Cool. Great. So quick update regarding the thermal test fixture. Um, so the last month we have this when we bring it up, Jason from Broadcom brought up like, well, shouldn't the opening holes on the thermal test fixture match OCP spec? That is actually a great input. So after some offline discussion, they'll have agreed that we'll match the OCP spec, 17.8 millimeter opening, the width opening. So I think we'll proceed with that. Just that I think Jonathan is also taking a long PTO, so we haven't have a chance to fabricate the the actual piece yet. Any more updates from Jason from Dell regarding this
No, I
piece?
think no, I think you pretty much captured it. Um, yeah, we discussed the opening. Yeah, we're in agreement that it needs to be per the spec. Yes.
Okay, great. So I think that's for this week. Jonathan gonna be back in a couple of days, so we're gonna get the 2D diagram. We're gonna laser cut it, band it, and send out for real testing. Okay, next regarding the OCP Global Summit. So as mentioned, we do have two abstract tentatively accept. Previously we say submitted, but now it's actually we know the abstract actually tentatively accepted. There's two topics. One is the OCP NIC this year's review, um, and then another one is talking about predictable thermal performance, which will be presented by Jason. So, Jason, you mentioned that you want to discuss a little bit about content. Is it like this meeting, or we're gonna have a separate
Well,
meeting?
I was, and then when I sent that email yesterday, I saw Jonathan still on vacation, and Anna, this is the other person that's also on vacation until the 17th. So what I'm going to do is set up a sub meeting with them and
I see. Because I was a
your
bit
team.
confused, but I don't see in our calendar, but we do have a monthly meeting. Okay, cool, got it.
Yeah, yeah. So we'll just have to pick that up in that little sub meeting. But the goal of it is discuss, what we've already been doing up to this point,
Mm-hmm.
break out how we want to present the information, and then yeah, I'll put together the presentation and cite everyone's contribution to it, but present it more as what we've done as a group for this, and then talk about the next steps in getting towards the next generation of speeds and potentially what we'll talk about here in the later in the agenda if there's a new form factor too.
Yep, that's right.
So this is a big topic. I feel like one session can't really cover it. Can we get more
Uh,
sessions? I know we proposed one. I'm guessing other people did too.
as far as I see, OCP NIC only accept. I would say the server work group only accepted this two.
Oh,
Um,
what kind of influence do you have, Damien? How can we work this?
the influence session is over. Yeah, actually, I would say the server group I think received like 40 to 50. I want to say 46 to 50 submission this round, and I think they only approved 22. So more than half were actually being deprioritized because there's so-called too many.
Okay.
But I
I
think we
wonder
can
if
work
we
the
can figure. I
content
wonder if we
in.
can figure out a way for us to get together there.
Yes.
Uh, you know, I don't know if there's other ways we can get space to have a community, right?
Yeah. So space for demo, if you have something to demo, is something that you can show and talk. We can use that, like the experience lab space. That is the space that we have. But airtime in the breakout session is only 2 slots. So we can work in the content, but then like the airtime is that's what we have.
All right.
Yeah,
And
Paul.
Paul, I think we can work together.
Yeah, Paul.
Yeah,
Why don't
I'd love
you?
to. I just I'm want to think about how we can do more together.
Yeah, follow up with Damien. Like the topic that you
Yeah,
didn't get in there. There's there may be a way we can at least get a subset of it in within these two. Probably be the
yeah,
first one, but originally when
yeah,
Damien put the first one together, it also included thermal. So we're not
yeah.
going to now have that in that particular one. So there is a little bit of space, but let's talk about it. This is not the end.
Okay,
hmm Yeah, the
great.
first one is more intent to be the catch-all, what our group has been doing for the 1 year. I think we get 20 minutes from there. So typically we only have like 15 minutes. This is 20, so we do get a bit of time. So we can work on the content. Another one is more like, yeah, we have space for the experience lab demo. In fact, if there's something that's more tangible, the experience lab demo usually get more engagement. I would say the breakout session, you talk, that it's more like one-way street. Um, it's more like a presentation. I don't really feel it's really a workshop. I guess that's one reason that they removed even the name. So it's called breakout session. It's less feedback from the group. Like I think experience lab have more engagement. Like we actually talk about it. People ask question, we answer, and then two-way communication is actually stronger on the experience lab. Personally, yeah.
Yeah, I mean, I think about the kinds of sessions we
Mhm.
had. I think there must have been 7 or 8 of them when we were developing the spec about
Yes.
different important topics to make it happen. And I feel like we're entering a new phase
Yeah.
with
This is
with
in
our high
the.
speed signals and form factors where we really need to start in that update that intensity. Back
Mhm.
to that.
Okay. Yeah, I think initially definitely a lot because it's new. Like DCMHS has a lot of acceptance this round mainly because it's newer and a lot more thing to talk about. So yeah, basically it's all about content, right? Yeah. And yeah, last I was mentioned about the Experience Lab demo again. So we do have space approved. So far we have 3 companies interested. I really would like to see more, but please send me a mail. I also will send to those in the past have been participated to get a bit more participation on the Experience Lab. And Paul, maybe if you can join us.
Sure. Uh, we could. I'd love to hear how. I'll think about it. Yep. But no, no. In fact, yes. No. We can certainly show a couple things. So
Yep, yep.
we'll
And
join you.
I heard I do have some chat with Thomas sometimes. Like yeah, I heard that maybe travel is approved, but maybe not approved, like possible. So
Uh,
yeah, it would be good to see you folks in
I
person
got.
if that is true.
I'm arguing for it. Yes. So I
Yeah, I see Becky online. Um, okay, let's move on to the next topic with Hammer gonna leave pretty soon. So ATI's test picture update, Jason.
Yeah. Um, so update on CBB, our assembles units arrived. as we were trying to get them assembled a couple weeks ago, we found we had another missing item, so that was taken care of. We just now got them
Okay.
Thursday, so I've sent them out. Our Dell SI team claims they now have some bandwidth, so I just gave them a board on Monday, and then I have two other vendors that have signed up, and I'm shipping them out boards today to
Okay.
test. So hopefully we'll be done with this one.
Okay.
I haven't
Mhm.
had a chance to do the IC meeting yet. I need to put that material together to release the CLB, but I have already started releasing that collateral to others, and the IOL team does have access to that information, and I believe they've been taking orders on CLBs.
I see. Great. For the IC meeting, you need to schedule also, right? Like,
Yep,
you might not get the immediate slot too, so you might want to, especially
correct.
when closer to Global Summit, that is pretty packed. You might want to get on a schedule.
Yeah, thank you. Sounds good.
Okay. So yeah, good. Thanks for your feedback. Next, Hanoi, on the SI for PCI Gen 6.
Hey, Damien, are you presenting anything? Somehow the
Huh?
presentations went off my screen.
Oh, is it?
I
Um,
don't know whether it's true for everyone or is it my side?
I'm
I
still
can see his
presenting.
screen still. It works
I
well
can
for me.
still see it.
I can see it.
Okay. So some reason. Okay.
Okay. But again, this slide come from you. I'm just integrating it.
Yeah,
So
yeah.
if you
So
want to, yeah, I'm actually on the first slide of your slide, the
okay. So let
crosstalk
me just
slide.
talk
Yeah.
to that. Yeah. Okay. Yeah. Yeah.
Yes.
So let me talk to that. So yeah. So I think we have been discussing in the background with some of the folks from Intel, um, Amphenol, Molex, and others there. So I think I think the proposal is that we plan to leverage the spec from which is coming out of from the others like TA, SFF uh, for one of the proposals like 1.4.1 that was for the connector. I think that's one thing we plan to use it. But of course, I think we provided our feedback there as well. What we really like to see the not much on the insertion loss, especially on both the crosstalk and the inter-pair skew and also the return loss aspect of it. And I think based on that, Anthony on that SFF committee, I think came up with those proposals, and I think those are out for feedback from the committee there. So certainly, I think from OCP Nick standpoint, we really don't like to create a new one and leverage both device side and as well as the connector spec uh, as is there. I mean, the idea is that if our requirements are met, and I think we can use it as is. So I think based on those proposals, we just wanted to check whether the channel simulations look decent enough so that that can be incorporated. That's one aspect of it. Another aspect is that if some device vendors, if they're willing to share some of their models, like the IBIS type of models, we can verify those channels to see that whether it really meets the RX spec or not. So I think I made good progress with the device vendors, and I think I do have one device vendor models with me. The other one promised to share that pretty soon. So I think we can do that. So I think what is really remaining at this point is that check the channel simulations. But of course, not all the components are ready for Gen 6, and some of them are from Gen 5. And we just want to, at the first pass, see whatever model we do have and see that whether we have a fair shot of making those specs that's being proposed through SFF TA there.
So
So
Tamo, I see
yeah,
two
go ahead.
tables in your slide, right? One is with the red word and one with the black. So I
Right.
don't think they're exactly matched. So which one is
So
newest,
I
or can you give us a bit of
no,
flavor?
I think there are two of them. There is one is in the device specs. So, I mean, if you are look at the picture on the right, the device
Oh,
encompasses the connector and as well as that the card edge connector along with that everything together there. But the connector is just purely the connector specific specifications. So there are two of them there because
I see.
I think that's
So
critical.
which
Yeah,
one is the connector spec?
the
The red
one
color
at the
font?
bottom, on the red one is the connector spec, which is there, and the one on the top table is for the device side Gen 6 spec. So, so I
I
think
see.
so when we design the OCP NIC, certainly we need to meet that device side 6 spec there. And of course, the connector vendor will adhere to the connector spec there, and they will show that, so they meet that spec as well. Yeah. So I think of both of them together, I think we can develop our system spec. But I think from our system study, I think we just want to do the whole channel all the way from host side, like the root complex switch, all the way to the device endpoint to see that we have reasonable chance of meeting it, to meet that the spec there. All right, so okay, now I think for me the slide came back. Okay,
Okay,
so go to the next one.
sure.
Yeah, so I think here what the preliminary work that we are showing is that the root complex slash could be another switch there. It's like a 20 dB along with the package model, and that the channel, the simulations of the model itself is shown at the bottom left half there. So I think slightly around 20 dB. Other plots are the crosstalks. The ones on the right is, of course, the reflection, and the others at the bottom side, which is like close to 50, 60 dBs, are all the near-end crosstalk, far-end crosstalks there. I just wanted to show there that, yes, I think we are close to meeting 60 dB, but some cases it goes to 50 dB there as well. But certainly, I think that's that coming from that the root complex, which is PCIe Gen 5. Current models are from PCIe Gen 5, so certainly there is a room for improvement to make them better there. And all to the extreme right plot there, which is that AIC OCP with the 7 dB plus the package model there. Along, I think that's also shows a slightly higher insertion loss there. So I think this is just a preliminary start here. I just wanted to see that whether how far we are. So combined everything together along with the connector model, thanks to Amphenol, I think we have added that together, and that's a plot in between, which we just want to meet that whether we can meet the PCIe general spec there. And certainly, I think we see that the insertion loss wise, I think it's pretty close to that 36 dB there. But I think the what we really need to pay attention is the crosstalk aspect of it. But I think here there is a PCIe spec, but I think it's whether we meet the PCIe spec. I think that's which is more like informative. It's really not normative there. So I think, but I think what is really important is that from device standpoint, whether we meet that RX spec for the device. And I think that's one of the critical things that we have to get to that and see that whether these specific channels do meet it or not. But in general, I think if I look at the crosstalks, insertion loss, I think we have a reasonable chance of meeting that once we dial in some of that other components which are geared towards Gen 6 specifications there. So in a nutshell, I think the message that I want to give it is that like still we need to do some more work. Some of that specs are still not yet defined, especially like that CC ICN comparisons. We cannot do. I think it's been work in progress, so we will also do the same on our side. And PX, I mean, Power Sum Next is also, I think they have tightened it up a bit. That's a proposal also there in the SFF committee as well. So those are still some of that variables there that we have to look at and see that how well we do. But I think in general, I think we are on the right track, I believe. But I think, of course, the device, the IBIS models from the device vendors probably will tell us a little bit more where we truly stand on our end-to-end channel characteristics there. So uh, I think this is more or less, I think I'm just working a little bit on my side, working some of the intel. So I think I just like welcome anyone who likes to have a uh, joint working session there to come up with anything better that we could improve on that OCP next side. So maybe I'll stop
Um,
here. If
I
there are
think
any
from
other comments,
OCP
yeah.
next spec perspective, right, there's two things that we need to define. One is to make sure that like the 7 dB insertion loss that we kind of spec is still workable
Mhm.
um in Gen 6, or we need to be lower or higher. Um, so another one is the connector spec, which is mainly driven by um the the the
EDS,
the
EDS,
1002 um
yeah,
is we have our input in there. So I think that
right,
is the two things that we need to define in this OCP spec.
right.
So
But
the,
also, yeah, sir, go ahead.
yeah, do you think we are sort of achieving that? And if
So
not, like when do you think we can achieve that?
yeah. So I think those are a little bit loaded to me because in a sense that uh, yes, from OCP Nick, I think this is the budget. Certainly, I
Yeah.
think that's one thing to look at.
Hmm.
The package models is all. I mean, like what I'm just my assumption is that whatever we had in Gen 5, certainly there is from the device vendor's perspective, I'm expecting that probably is gonna be improving a little bit. How much I just don't know enough. But that's just that from a system
Mm.
simulation perspective, that's just only one piece of the pie. Other piece of the pie also you need to plug it in that root complex switch. I mean, at the end of the day, it's like either the end device meets their RX spec or not, right? So
Hmm. Yeah.
I think certainly OCP NIC standpoint that is important, but I think the overall perspective that the crosstalk and insertion loss that also needs to be within that PCIe spec as well. So I mean, I'm reasonably confident that yes, I think the 7 dB number can be achieved. I don't think that's a big deal. The package models, of course, whatever best that I know at this point, and certainly that's going to improve. That's for sure. And mm, yeah, so I think it's we have a reasonable shot at making it. So I don't think that we are far off there. But I think as I mentioned that that device simulations probably would give us a little bit more indication that where we truly stand at this point, even with making a whole lot of changes to the previous generation
Mm.
models like Gen 5 models where we
Okay.
stand
So basically, to increase the confidence, you are suggesting we actually work with like a Gen 6 root complex or switch vendor. I don't know who have that. Right. And then the NIC card switch NIC vendor that have Gen 6 model plug in together and see whether the overall channel I is okay, for example. So that if
there. Yes,
that works out, then you are more confident that this is good.
yes. Yeah, I mean, I think from at least OCP standpoint, yes, we define a spec, but also as more confidence, yes, certainly I think plug it into a system level end to end and see where we stand as we plug in that OCP related numbers there. Yeah.
Okay. Any vendors like in the car today would like to offer that model?
I do have access to one. I'm just not like, I'm not sure how comfortable they are sharing that across, but at least
Yeah,
I have an
that's why
access.
that's why I want to like
Yes,
open it up here and see whether we have any
yes.
vendors here that are
So
open to
I,
do.
yes, I do have one. I working with another one, which is uh, will be available in a
Yeah,
couple of
under
weeks' time.
NDA, I know who have the the
Right,
models, but
right,
just from
right.
an open source perspective, I want to see who anyone want to
Yes. I mean,
want to open
yes,
up.
Yes, yes. I don't have any sort of an indications whether they're willing to share that. So, but I think I'll work on that aspect of it and see that if
So
they
you're looking for an
like
IBIS, a Gen 6 IBIS model, just to be clear.
exactly, and if
Okay.
the vendor is willing to share that, yeah,
In
in OCP space, yeah.
yeah. Okay. We'll see. I'll think about it.
Okay,
Yeah, or
and
another
yeah,
way, if we don't have, then we can work on the NDA side and say we have tested CPU A and NIC A and it works. Just that we don't say who's A.
right, right. No, I think that's the better way of, yeah, that's another way of
Yeah,
saying that. Yes, we had
yeah,
access to A and B models, and both of them looks reasonable. Maybe I think we can have some confidence to move forward there.
yeah. And we can even show result, right? Just that we cannot release the
Yes,
name
yeah,
if
yeah,
they don't want to use the
yeah.
name. Yeah, yeah. Let's work on that for the next month. I think that will give bit more confidence.
Right.
Um.
Yeah, in the
Okay.
meantime, if yeah, if anyone else they like to join, and I think I'm thinking more like a SI-centric sub meeting there. If
Yes.
anyone
I
else
think
like,
previously in Intel they are also a pretty strong proponent in the SI work group. Maybe
mm,
you can share with Submit a bit more. I remember it's to the maybe a few more like even Keysight. Like they are pretty active there. I think it's good to at least see two system vendor channel simulation before we lock down the spec. Like yeah, especially meta form factor is usually not the sole standard compared to enterprise.
mm,
Um, okay, I think we need to move on real quick. But yeah, we'll keep working on that. And maybe we'll talk to Dell as well to see if we can share some channel simulation. Cool. Next, let's move on to the the new form factor discussion. Anon, go ahead. Anon, you there? Oops, did I
Hey,
lost you?
Damien. My name's Harvey White. I've been working with Anon on this. So
Yeah.
what's being proposed here is one of the problems we're trying to solve is today, as everybody knows, there's two form factors as far as width for the NIC card. You've got the standard
Hmm.
width and you've got the large form factor. And what this slide is showing is to use the large form factor requires a different motherboard because the second connector is not the same. It's
Hmm.
not a 4C plus. So that means motherboard manufacturers have to make two different motherboards if they want to have the ability to support a large form factor. And
That's
in
right.
today's economy, especially with the proliferation of CPUs and compute elements out there, um, it's that's a large expense to put on them to make two different motherboards if they want to support two. So
Hmm.
what we're proposing is to take the existing motherboard spec, has the specification for two 4C pluses. This is on the DCSCM, you know, specification. You can have two 4C pluses and they specify the dimensions, where to place them, the whole bit. So by
Hmm.
using that specification for that board, what we're proposing is to make what we're calling a DFFF or double wide or double width form factor. Please move to the next slide. We'll show that.
Sure.
Uh, that has two 4C plus connectors in there. So what that lets us do is plug this into that same motherboard that can accept two single width cards. We can plug one of these in. And the problem that solves is it gets us 32 PCIe lanes for high speed network adapters. So for what's upcoming is, as we're all trying to get to 800 gigabit per second transfer rates, we need 32 lanes at Gen 5 to reach that. Also for multi-host network adapter type devices where you want to be able to have multiple sets of lanes into the platform. This takes care of that as well without requiring a separate motherboard. What we'd probably look at on the top, you can see it showing the tall form, the tall height and the standard height is shown. Most of these probably I envision would go out with the tall faceplate, simply because we'd be using an OSFP style connector, as we're trying to go to 800 gig, transfer rates. The other thing it gets you is, since you've got 32 lanes, you also get double the power. You have 160 watts since you're pulling from both connectors, and then you get roughly 13% more PCA or PCB board area space, because the space in the center is now able to be utilized as well, between the two cards. Things we're looking at, a couple proposals we've got for management schemes. Obviously, the FRU on the card would identify lane usage, because since you've got two connectors here, there's a couple of use cases you could envision. The first is, like I mentioned, where we'd have a network adapter or network device that's capable of using all 32 lanes, and it would identify itself as, hey, this is the the DFF, the DSFF form factor, and this is how our PCIe lane mapping will be. Identify that to the platform management so that it can tell the host BIOS how to configure, properly configure and use the card. Another use case could be, well, probably not as likely, would be to have two separate devices living on the same card, each having their own interface into the system. And the only reason you might do that is if you were after additional space for whatever reason. And then the third would be, you have a NIC device or a endpoint device that is connecting to multiple different hosts and multiple different domains. That is probably the least likely, because that brings in, as most of us on the call realize, when you have a common device that's connecting to two different PCIe domains, hence nodes, when one of them powers up or down, the device has to be able to handle that properly. But again, in that use case, again, the FRU would identify it as such. The other thing is, one thing we would propose as well is, for chassis designers, you would have some sort of removable center rail that you could insert or take out of the chassis to allow, the chassis to be flexible, and whether it supports two of the standard width, or two of the SFFs, or one of the double wides, in the same chassis, just simply by removing that center rail.
Yeah, I think I sent this out like 2 weeks ago to a small group of CLA members. So I think some of them are actually on the call today. We would like to hear from the community. You think this is something we should pursue? We definitely would like to recover from our not so popular large form factor and learn from that and see whether this makes more sense. Open up to the folks to comment.
So this is Warren from Lenovo. Like you saw my feedback.
Yeah.
One concern we have with this is really the structural integrity of the server, especially when you get down to like a 1U size, where now you've got this really wide opening in the back, and the whole mechanical structure can flex. There's not any support in the middle of the server, right? It'd be really easy to bend. So that would have to be some problem we have to figure out how to get around. So maybe.
But that's something you'll also have to handle if you're using just a regular large form factor, wouldn't you?
Yeah, but we're not supporting a large form factor.
hence the problem.
Right, we haven't had to deal with that problem.
Yeah. No, I
definitely hear what
you're saying. I definitely think that's a solvable issue. But yes, I hear what you're saying. Yeah, we have to make sure we don't have sag or warp in the chassis design due to the cutout space.
Right. The other thing I was going to comment on was how you were going to accommodate the slide rails if you just had a single adapter and not the wide one. Now you already mentioned a removable thing, so that's an idea.
Yeah, that's something we've been looking at, is having a removable center section that's easy to install and remove, so that way the same base chassis can be used for either, and even depending on how it's implemented, it could even be a end user, like if they want to switch to a wide card, they could remove that center adapter.
Yeah, something like that would have to be there. And also about, like, if you had two single adapters, we use the thumb screw type. One of the adapters, thumb screws, doesn't have anything to go in the current setup as well. So I don't know how that would work.
Yeah, I think the thumb screw, I think that's a problem we get even if you're trying to use two of the small form factors in a chassis that was designed exclusively for them, because I think it impinges slightly onto the space of the second card, the overhang on the bracket.
I think a thumb screw is not supported according to the DCMHS.
Yes, exactly. That's correct.
Thumb screw is not supported in DCMHS?
Whoa,
No,
say that again?
in the proposed, if you can go back one slide, the
Sure.
proposed left side image, right, is taking from one of the form factors presented in the DCMHS, where you have the upper SFF and then the lower management module, right? And then in the middle, it's kind of a flexible area where you can either use for a large form factor or for an additional SFF. Now, this additional SFF, as you can see, is quite tightly located next to it. So even here, let's say the center SFF does not have a room for a thumb screw. Yeah, the upper one, potentially you can, but the middle one
But be
anywhere.
careful though. Be careful, because the DCSCM also has the ability to have an internal version that does not have the thumb screw. So if you use the DCSCM that does not have the thumb screw, you can now use thumb screws for both of those SFF cards.
I don't think that in this spacing.
I can promise you can. We're doing it today.
On the opposite side of the
opposite sides of the DCSCM.
Oh, I see what you did. So the faceplate has thumb screws on different sides so that they can fit next to each other, the small form factors. Okay.
But then is the spacing between the two small form factors like shown here? It's following the DCM.
You can put the DCSCM in the middle and put the two OCP NICs on either side.
Oh, yeah, I see. But then it doesn't follow.
But that breaks the LFF topic that we're talking about, right? But it is possible to do that. I guess that's my point.
Yeah. So I think the topic here is, if one wants to design a server that looks like the left side, and now also want to utilize a larger card, then this is the offer that we're trying to bring here. Obviously, if you design something which is not according to the spec, you can do a lot of cool stuff. But I think the motivation here is to bring a form factor which will be able to utilize in servers built like the left side, which according to Harvey is
well, Arnon, I'm missing. You're saying not per the spec. I'm confused. What's not per the spec?
Yeah, no, what we're talking about here is the motherboard you see on the left. That's from the OCP MFLW form factor base specification that's where they're proposing the two connectors get placed.
I see. Okay.
Two. So what we're saying is, if someone follows the specifications to build that motherboard, which will support one or two small form factors, we can also support what we're proposing as the the DSFF, or the double, on that very same motherboard with no changes to the motherboard as far as physical connector placement.
Exactly. Name open for suggestion, by the way. This is just yeah. And
actually I didn't take on my bad is I didn't pay that much attention on this particular one, which I felt is a little bit of a problem, that is only an internal latch can fit in.
Correct.
Yeah, that's a big problem for us. Our whole portfolio right now is thumb screws, OCP cards. And if this means that we would have to duplicate all of those SKUs in internal latch, that's, I mean, it's just parts to have to add.
Yeah, because that's true. If you're doing the double, if you're going to support the, the twin connector, FLW motherboard, and be able to support twin cards, yeah, they're going to have to be internal latch because the spacing between the two cards is too close for
Well,
that
at least
center SFO card.
the middle one will need to be right. I mean, the upper one can still have a thumb screw latch.
Correct.
On,
Yes.
On
yes.
the north side, but yeah. But again, I mean, question is, do we see a value? I mean, I think this is just a bonus.
I
The
think
bonus
some
that,
details that we need to work through, but yeah, do we see a value? I think let's go with that. I agree on like, do you see a
Yeah.
value? Then we work through
the
the
question,
details.
yeah, whether we should pursue. We have, as
Yeah.
I said, we have mechanical challenges that we need to solve, but I believe that are solvable, or that there are trade-offs that needs to be made by the server manufacturer, like the internal latch, etc. I think a deeper problem we need to go into, and will take some time, is to solve the management scheme and decide what kind of
yeah, even latching mechanism, I think is something we need to solve.
yeah, we need to solve. I'm saying I think these are all, I wouldn't say simple, but easier to solve problems, or quicker to solve. I think the long pole will be to understand the management scheme. What happens now? This card has two management connections. How do we treat them? How do we connect to them? So I think that's something that we also need to dive into once we feel that there is interest from the community, and that we want to pursue with this idea.
Yeah, I think for management, it's different, but not significantly different from large form factor. I think Yuval from NVIDIA and Thomas from Intel has been spending a lot of time on that. Previously, I think we can tap on their expertise.
Yeah. Hey, and Damien too. I'd like, from Dell's perspective, we'd like to see NVIDIA also present this to the DC MHS group. And it's not necessarily because of, this is Nick. However, there is a lot of still active members that are very focused on the rear form factor and mechanical expertise. And some of the items that Lenovo listed, there's some similar concerns Dell has, and that's why we'd like NVIDIA to also pitch this over to the, or at least, guide this over to the DC MHS, because they're already looking at sizing for other aspects too.
Yeah, especially the bigger 21-inch one. Make sure we at least put in the thumb screw. I think 90-inch may be a bit challenging. Yeah, I think that makes sense. I can make the connection with the CMHS and NVIDIA to present that as well. But from a NIC group, like we do have some server vendor here, do we think it's something that we would like to see? If yes, then we work out the 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 challenges ahead. Personally, I see this better than a large form factor that we have, just from like ability to use two small factor if we can. One of the reason I believe large form factor is not popular is because we need system vendor to make a choice prior. Like you need to make a choice prior. Whereby this you can make a choice after. You can design it first. And then depending your use cases. Maybe you use a normal performance NIC, you can use this two small factor. If you need maybe a smart NIC later on, if your customer needs it, you put in the dual. I feel like that flexibility is probably appreciated. But that's my thought. But then I definitely also would like to hear from the system vendor side. Do you see value?
I see value of what was presented verbally, but not in the slides. The specific 800 gig requiring 32 lanes in Gen 5, the support for multi-host by leveraging two SFFs. I personally see those are two really good benefits. So I view it as beyond 800 gig, there's always going to be a bleeding edge uh, speed, and this may gain us that where we may not necessarily have gained that from another method. So from that perspective, that'd be the area I'd focus on. But I think there is some mechanical challenges and acceptance that has to be gained before I think we start diving into management scheme.
Yeah. Yeah, Jason and Damien, I can send you some additional collateral that you can send out to the, everyone on this call. I don't have everyone's email address.
Again,
That
yes.
that's much more detailed. And so, Jason, that's what it points out is the things you just talked about, the advantages.
Yeah, these
Yeah,
are just
thank you.
two short slides just to get the attention. And another thing that is not only about the bandwidth, it's also about, we're reaching to the limit where we can actually cool an 800 gig NIC, and we're also looking at the 16 or 1.6 tera. I mean, on a small form factor, we're kind of reaching the limit from power delivery and thermal. Having this additional real estate definitely give us benefits, and we're starting to look at large form factor, the existing large form factor, LFF, as a solution. But again, the problem was always with the LFF is the adoption. It was always a chicken and egg
Yeah,
situation
correct.
where we
Because
were asking,
yeah,
please.
agree. Yeah, I do agree because if it's a large form factor, you need to predetermine you need that, and you cannot do it after the fact when your customer needs it. Maybe your only 5% of customer needs it.
Yeah, only
95% doesn't need it. So you do have a choice if you use this. I see the value from that too. Anyone that kind of think that we shouldn't, I feel like talk to a few people on the side. I think what I hear is positives, but I don't hear like people anyone that think we shouldn't, and definitely would like to hear why. Of what maybe it's something that we did not consider. One thing I always skeptical is regarding how much of the faceplate from we are okay to so-called use as a NIC. Any consideration here? Because another way to make up space is actually go deep, right? Like for example, this one, rather than using the faceplate as wide, another idea is to go deep, like contrast to go deep, like from some system vendor perspective, is there any preference or either is fine?
I can tell you this. We've
Mm,
looked at it from NVIDIA side. So
mm-hmm,
going deeper has, first of all, you don't gain additional lanes from PCIe because
mm-hmm,
uh,
yeah,
assuming the interface only comes from the west edge here
mm-hmm,
shown, so you're still stuck
yeah,
with the same form factor approximately of connectors. So that's
yeah,
one. Second, thermally, you gain less from, assuming the airflow goes from left to right or right to left in this
mm-hmm, mm-hmm,
picture, then
yes, yes,
increasing the width doesn't helps more than increasing the length. But yeah, I agree from a faceplate resource management point of view. You're absolutely right. It's better to go to go deeper than to go wider. Yeah.
But going deeper doesn't give you any compatibility with existing parts. I mean, that's one of the good things that OCP has had. Even in OCP 2 days, we added more connectors and all, but everything was always compatible with old stuff until we couldn't
mm-hmm,
do it anymore on 2 and we went
yeah,
to OCP 3.
yeah,
The thing that's good about this proposal is I can use my existing small
OCP3,
form factor cards.
yes.
And
That's
that's
why I
why
like
the
the
thumb
idea
screw
too.
thing is a hang up for me because I can't unless there's a way I can use those cards. So I think
Yes, I
compatibility
think
is
we need to resolve
critical.
the thumb screw thing. I feel like there's something we should pick in. Yeah,
Yeah.
the compatibility. I mean this that dimension here is first off, right? Maybe you can adjust a minor and try to squeeze in stuff. But
Yeah, and obviously
personally, I
the
like the
double
idea.
width. Yeah, the double width doesn't preclude using a single thumb screw on the what would be the upper edge of that picture, meaning making it backward compatible with those that want to do a faceplate that has thumb screw, since they would have a thumb screw on that side for a single width card anyway. But yes, these are all things we need to iron out and resolve.
Yeah.
The one comment that I would have, Damien, is, you know, because we're going to add potentially another form factor here, we need to control how much variance there are. For example, in the original spec, we had I think a 11.2 millimeter height, and we went to a TSFF just for
Yeah.
additional cooling capability. So we're adding a DSFF. Are we going to make a TDSFF, or are we going to control the height as tall, you know, to begin with? Like, or
Yeah.
you know, how do we make sure existing cars today? And I think this is echoing others' sentiments.
Yeah.
How do we make sure existing cars today would be compatible with this implementation, right?
Yeah, Thomas, you bring up a good point. I envision that a lot of the use cases here are going to be for high speed, you know, network cards, obviously. And a lot of that's going to be the OSFP connector, which means that's going to require the tall faceplate.
Yeah.
Yeah,
I
but then
would
on the other
say
side,
that if we were to do it like this is so-called default, but then for folks who want to put a PCIe card on top of this, I would like them to speak out whether they need the SFF faceplate. I think that was be the reason to it. 1U PCIe card on top of a NIC, like I think we talked pretty long at some point. Like TSFF have some challenge from a
I think that
system one. Yeah, go ahead.
obviously we're trying to go into a slot where there were already two SFF slots. Now, if these two SFF slots were built for regular SFF, not the tall one, then why shouldn't we also allow for a regular non-tall double SFF? But I agree with Harvey that most probably all the high performance use cases will use an OSFP cage will mandate the tall form factor. So now we need to see whether the system can accommodate both tall and short from the faceplate point of view, and also going from two small to one double. All of these are mechanical exercises that we need to take.
Yeah.
But I think that if we'll end up putting it into the standard, into the spec, I don't see how we can choose just one, just T, and not regular SFF as at least an option in the spec.
Sure, that's a great point. It's just how do we mitigate what an end user wants to do with this slot? If the opening can be configurable as a tall or non-tall, kind of faceplate opening, that's fantastic. But what does it look like if you want to put a PCI card over it? Does that work?
I felt that this is the tall and non-tall are determined by two things. First of all, is one OU versus one RU. That is the second one is if it's one RU, whether the vendor would like to put a PCIe card on top of the NIC. If yes, then it's more like this choice. If it's no, then the one RU can do the TSFF also. I felt that that is more like a system choice.
Maybe this is not as big of an issue as I'm thinking. It's just a matter of what does a baseboard vendor want to support in the beginning, and then you can figure out if the opening will support tall or normal. But the main point is just kind of trying to control the proliferation of variants of cards, because what I don't want to do is have NIC vendors or even baseboard vendors be stuck in a specific corner where the opposite party only offers it in a certain way, right? Then you can't use this card that's supposed to be open, rather compatible architecture, and you're stuck.
Hey, we're at the top of the hour, and I think this conversation is super important. And I don't want to wait 3 weeks to keep it going. Damien, what do you think about another, maybe a virtual workshop, and even maybe leading to a something more, perhaps, if we can all figure it out? sooner.
Yeah, I think we should do it fast. Like I feel like we have quite a bit of alignment. We can even schedule a weekly one.
Let's do
Maybe
it.
we can have that workshop face to face at the site of the conference. I'm not sure if we'll be able to resolve everything by then, but it's an idea.
Yeah, no. Yes, and for sure.
Yeah, and that's yes.
Cool.
Okay, I will try to get some airtime into MHS and then also schedule a next week for the follow-up conversation.
If anyone wants to, bring mechanical ideas, we'd
Yeah,
love to see them.
and then we can continue to use our CLA member thread. Like I think we can, if you don't mind, you can actually share it over to other companies too. Like I know some companies share directly with me, your input, but so far everyone has shared directly with me has been positive. That's what I can say. So I see it's a good thing. Yeah. So okay, great, good discussion here. So thanks all. We are at top of the hour, and yeah, let get this moving. Interesting time ahead.